everyone, welcome to the Python lab, and today we try to do the practice on statistical analysis of any sample data. So I would like to use one statistical popular method, that is one sample t-test here. So I would like to apply one sample t-test on some samples. So first of all, we have to think about any real world problem. The real world problem, you can see here, there is a one nutritionist who basically claim that the average sugar content energy drinks about 30 grams. So they are saying that if there are example thousands or 2000 energy drinks, they are usually claim that there is a 30 grams, that is a mean value. Actually, the energy drink has a 30-gram average sugar content. So what we can see here, we want to test on any randomly samples of energy drinks. Okay, so we want to check about their sugar content in the unit is the grams. Okay, and here we want to check the samples average, whatever we are considering, that are same as the mean with the population or not. So practically we want to find out the average, that is the mean of our sample, and we will test with the assumed mean, that is the hypothesized type of a mean here. Basically it is a assumed mean, or it can write like a mu. Okay, so remember it will be given to us. So in our task it should be given that what is the average mean of the population. So practically this is the population mean. Okay, so we want to sort it in the Python language. How we can do that? That is the our task for today lab practice. So first of all, what we have to do, for we have to be check out a very important package. We need to use it because in data analysis we use a very important package, that is the numpy. So you can write a numpy here. Okay, if there is not, you can install very easily with the numpy. Example here, I can show you example pip list. So pip is a command which can help to install some packages. So right now I have already there, so I can show you it is there or not. You will see here that is a pip list. So it will give me the some list of the packages which is right now working in my uh, terminal here. Right now you will see here there is a numpy here. Okay, this is the version and it is there. So I have more packages which I mostly use, but you can do it very easily. Okay, so here how you can install it. So it is very easy. So here you can just write a install command and write a numpy here, and you will see here it will install, it will start installing for you. Right, if it is already there, it will tell us yes, it is already there, there is nothing. Okay, so this way you can install the numpy. So and here what I wanted to do, because I will import the numpy and then I will use to create a short abbreviation. So short abbreviation mean to say numpy np. So np is a short abbreviation, just like a aliases. So I want to create a aliases of this library. So in the future, I can use np as a object anywhere in the system right now. This is basically short names actually. So I will use it in my task here. And second is because I wanted to discuss that I will use the one sample t-test because numpy has not a t-test, this statistical method, which is most popular. So that's why I will use a one important scipy. Okay, so numpy basically is a numerical Python, and scipy is just like is for the scientific methods or scientific calculation. So I would like to use a scipy here. Okay, so that is important to understand. That is because scipy will hold, library will hold my sample one sample t-test. There are a lot of uh, statistical functions there. You can use it very easily. Okay, and also you can use example from uh, especially if you want to uh, import special package. Example from scipy import stat, it is also can be used. So you have two options, you can try this one. So if you want to go for a specifically package, you can use a scipy import stats. Okay, so these are important. So one sample t-test will be used by this. Okay, and some other numerical computations which I will use, example, sorting the data, or some addition, subtraction, or something like that I wanted to use with this numpy. So basically it is the numerical computation, if I can use it, because I would like to create some mathematically about some statistical methods. I would like to use it. So guys, here, these are the important headers. We need it in the package right now in our task. Okay. So now let's try to see here what we can use here. Let's see. We have, because try to understand how we can find out. So we have to see. So question is, we will see here how we can find out a difference basically. So if you want to find a difference, so we need to calculate the t value. So t value just like a difference actually here, right? So t statics we have to calculate. So how we can calculate this, the t statics? So here you use a example. This is a basically formula, sample mean. So guys, you will use you need to use or calculate the sample mean. Sample mean to say whatever the sample you will take it, you will need to be take the average. So that is the sample mean. So here maybe for your easy understanding, I can write here x bar. So if you know, in statistics and mathematics we use the x bar. So I think it is good I can show with that. So first of all, I would like to measure this x bar. I need to calculate. Okay, and after x bar, what I wanted to use here, then the formula, basically I'm writing a formula right now. So uh, I have to minus the assumed mean. So assumed mean is example mu here. So here I can write here. Okay, or so here it is a good idea to understand. So this is my equations. This is the formula which we can use. So first of all, we have to calculate the mean of your own sample, then which is already given to you. You can also try this one for calculating your mean as well. So idea is to be find out the difference. So basically in the beginning you can see I started to have a difference basically to find out the difference. Okay, so now this looks like a difference. Okay, and then after what we have to do, it is not enough because this is not a formula right now completed yet now. So what we have to do, we have to be divide the whole expression here. I can write a for in this form. I think it is good. Okay, so if the difference will be divided by we have to divide it by the variance, standard deviations. So I can write here st. Okay, so the whole difference I need to divide by st, that is a standard deviation. Okay, so that is important to understand. And then after what we have to do, then we have to be divided with the square root of the sample size. Sample size mean to say n. Okay, so this is basically the general formula to find out the difference actually, that is the t statics. So t is a just like a residual, standardized residual. So we are going to be calculate the standardized residual here practically. So this is the formula to find out the t value. So this way we can easily find out the t value. Okay, and here one more that is important to understand. What we can do here, we have to be also check out the standard error. So practically here standard error formula is the same here, which I can show you here. uh, that is the formula of standard error. So standard error is nothing. Standard error will tell us what is the gap actually, right? How we can see what is the actually standard error. It should be less or minimize as much as can. So here you can also write if you wanted to make it a shorter here. So practically the whole difference we need to divide by standard error. So standard error formula you can put separately here. Okay. So guys, in this way we can easily find out our t value. Okay. Now, so can you see here? Let's start our script here. This is a assume mean. So let's see, assume means equal to 30. It just we are getting it. It is just post. Okay. So anyone can give you the in advance that this is my population mean. Okay, so this is you can store this main into the variable. So variable is mu here, and then after what we can do, we have to be, suppose we want to check example sugar content. So sugar content, you have to create one more variable. So it's not a simple variable, you can create a some list here. So in the list you can put example some grams of a sugar. This is a quantity, it is written here example, can you see here, random sample of 15 energy drinks. So I will put some 15 energy drinks grams here practically. Okay, so example 34, 28 and 30, and let's see, this is only for the samples. This is a random sample here which we can do it here very easily. Okay, and here you can put here. Okay, so you can count only 15 here. 1 2 3 4 5 6 7 8 9 10 11 12 13. 2 are more needed. Okay, now you can see this is the list is created. So okay, so now I can created the list very easily. Okay, now first is what we have to do. We have to find out the, let's see, go by the very easy example size. So here, how we can find a size in the Python language. So please remember, please have a look in my last some video where we have used some inbuilt methods here. So what I wanted to use here, so I wanted to use a important functions, that is the length. Okay, length of the list. Okay, so here you can write a, this is the length of the list actually. So here you can just print very easily. What, how you can print? Example here, you can write a sample size here, something like that. Okay, and this will be here. Okay, and let's try to execute this script here, and let's see what is the sample size. And you will see here sample size will be come out. I hope it will be there. So let's see, it will be come out around 15, I think. Okay, this is the first task, we need to do that. Can you see right now here it is coming, and I can write a comment sample size. This is the first task. Now next task will be the uh, sample mean. Okay, so if you want to find out the sample mean to say the average, so then very easy, we have to be use a, what I will use, we have to use this numpy. Okay, so numpy has a very nice function, that is the mean. Okay, so I can store, I can call the numpy package here. Okay, and here I can use a mean, and what I have to pass, the list, simply list, pass your list. So this average will be stored in this variable. What is the name I have given? Average, avg, whatever you can give. This is my sample mean or average. This is my sample mean actually. And now if you want to print, what you can do, just I can copy it here. So sample mean here, I should write a sample mean here. Okay, and here give the variable name, and you will try to check out the sample mean is coming. Yes, it is coming here. Now can you see your sample mean is ready? So you can also see we are using the descriptive statistics here. Okay, this is the descriptive statistics, the major part of the average. So this is important. And now, apart from it, this you can see it is a very long after decimal places. We can use a very important functions, round functions. Try to round off. Okay, so here you can round off the average by 2. Okay, I hope it will give the our 2 decimal places for better reading. Yes, it is good. So now I can calculate the sample mean here. Okay, so I can show you sample mean is ready. And then after, one more is pending, that is the sample uh, standard deviations. Okay, so here you can write here st value, And here for standard deviations, uh, we have, I think we have to be check out, we have to be standard deviations std, yes, std should be here, and change with this. So now guys, you can check out your standard deviations, your sample st. Okay, so now you can see here, this is the sample st, and change the variable. Okay, now you will see your standard deviations will be also ready here. That means the value is deviated by the average from the average 2.8 around 3. Can you see right now? So this is the average value. Maybe it can be lower 2 unit or maybe maximum 2 unit above the mean. So this is guys, here we can understand that we need to be find out the basic statistics example, average or standard deviations we need to be calculate very easily. Okay, so now next task is to be try to do out example what we can do here. So important is to be use to be one more here. You will see somewhere here. This is also need to be important to check out. Basically, this is the delta degree of freedom. Okay, because we don't want to be biased. We need to be unbiased actually. So if it is a bias, it is not okay, because we are thinking that we need to be uh, calculate the standard deviations of the samples which we are considering of these samples here. Okay, it should be unbiased. So in what case we can assume we have to set the value 1, because the mean is from the whole populations. So this is our random sample. So we have to be justify that we can easily use the different type of a sample. We have to be set this value dd of, okay, that is important. That will show us this is a different type of a standard deviations here practically. Okay, so basically we can say this is a delta degree of freedom. It will help us to use a real sample mean actually. Okay, so another way you can see this is a Bessel corrections here. Okay, so here you can see here Bessel correction actually for real mean actually, right? So real sample mean, because we have to justify we are not the bias, we are unbiased here. That's why we need to use that. And then you will see here little bit change you can find out here. That's why you see the deviation will be very accurate right now. So guys, I hope you can understand in this way what we can do here. So we easily count out basically our standard deviations here. Okay, so now what is the next task? Next task is to be standard error. So standard error of a mean. So let's try to see standard error of mean. So as I wrote here, we need to be find out this formula, standard deviation divided by square root of n. So here we can easily again create a standard error here. So create your own variable se, okay, and here you can give your sd, okay, or give the good name std. This is good. Okay, let me, because it will be the same here. The better to be use the different one. Okay, so what we have to do, we have to be divide. Now we need to be use a square root, but here np will help me. So np is the lic. This is my numpy. So here I will use numerical Python here. So np, and I can find a square root somewhere. This function I can help you. But in this function, what I will pass here? So I have to pass the size, and size is already there. Okay, so I wanted to show you size is already there, which we use with the help of length functions. So now my standard error will be also ready. I hope you can see here. I can put it here, standard sample error. Okay, now just change this variable and see the result. Let's see here, standard error, sample standard error is a 0.7. Okay, that means it is a lower, less than 1 it is okay. So basically standard error, it will measure how accurately the sample mean estimate the population mean. So practically this is important, it should not be high, it should be lower as much as, so as much is lower it can be show the precise estimate actually. That is important. Okay, so we are able to find out the standard error now. So now you will see here we are able to find out the mean, we are able to find out the standard deviation, we are able to find out the standard error. Now just need to be put this whole idea in that whole equations actually. Now, what we can do, estimate t static. Okay, so t static we need to be calculate here. So if we want to create a want to calculate the t statics, so very simply what we have to do, so we have to be create a variable t stat. Okay, now you can put your whole equations here, so whole formula actually here. Okay, so how we can find a t stat here, so important is to be check out because here that is the important to understand. So how we can find out the t statics here, so here the formula is here you will see this is the average here, that is the average of here of the mean average, this is the sample mean and this is the, and then you can divide with the standard error. Okay, so here how we can do that, so idea is to be used here, average is here, this was the average of my own sample. Okay, this is a real sample, random sample, and we have to minus here mu. Mu is the assumed hypothesized type of a average mean. This is the population actually, this is the sample mean, this is the population mean, that's all. Try to understand, so just find out a difference, and then after we have to be divide with the standard error. Okay, and here we can easily print out again uh, this t value or t statics, whatever you can write here up to your choice, t stat here. So let's see, t stat will come out here 0.35. Okay, so guys here you can easily find out the t stat. Okay, so that is important to understand. So how we can found the t stat, so t stat is very important, that is a basically type of a not a residual, just like a standardized residual, think about. So it will basically calculate the uh, way how much it is a far from the difference actually, this is the difference actually. So practically here you will see 35 here, so 35 mean to say practically you will see here the sample mean is about 0.3 practically here, or which is the standard error above the hypothesized mean here. Okay, about 30 grams here which we're discussing here. So that is important to understand, it is a lower than 0.5. We will talk about the next probability value. So now able to we find out the t static value. So you will see here this is the basically difference, it will be the it is right now positive. Okay, the positive, that means here the population mean is a not a higher, sample mean is a higher right now. Okay, so if it is a negative sometime come, that means a sample mean looks like a lower. Okay, this is show the only direction, nothing else. So here basically we are able to find out the t statistics. Okay, so we are able to find the sample size, then we find out the average, then we find out the standard deviation, then we find out the standard error, then we find out the t value. Okay, now we try to find out the uh, probability of this difference. So here guys, we also don't forget to what is the probability of the difference, this is also important, because yes we say this is the difference actually, this is the difference 0.3. Okay, and that means we have to think about how we can find out the probability. So for find out the probability, we need to be just create a own variable, example p value. Practically here, you can also write here, this is a p value, okay? And here you can write here p value. So you need to calculate the p value. So calculate the p value is also important with the rule of statistics. So how we can calculate the probability? So probability of getting the sample mean, basically it will equal to the closer the hypothesis mean. So how we can do that? So because we need the t value first, that is the t stat value here. So here I need a t stat which is already I calculated, okay? But before that, what we have to do, we have to be check out a, because here you will see in the beginning I just directly imported the stats module, but I need to use directly it here. So here what we can use here, the stat as t, okay? So I can create a analysis here. So here what I wanted to use, I will use a t, it is there. And now after dot I can access whatever I want to do. So after access I can easily find out the important, that is the cumulative distribution function. In the short we say CDF. It should be here, CDF. Here if it is not coming, then there is a we have to be check out in a different way. So here we can write uh, from scipy here, because this is the library, I can call the module here, okay, as t, import t. Yes, this looks now also good. So what I wanted to use here, then I will see my CDF. Can you see? So I can found this cumulative distribution functions here. So guys, that is important to find out the probability. So cumulative distribution functions of the t distribution for the two tail. So here that is important. Okay, so now I can use a t dot cdf. This is the functions here. In these functions, what I have to pass, my calculated t stat. Okay, so it will calculate it. But I can here I found I need absolute value, actually absolute value, right? So this is the absolute value of t statistics. Okay, so I need to calculate the absolute value of t stat. Okay, and one more parameter you can also find here. There are some arguments over here, that is also one is missing here. So cumulative distribution functions of a given RV here. That means I need to put a one more important, that is the degree of freedom. So degree of freedom mean to say the independent variable or samples here. So degree of freedom here you can calculate here. So formula is one sample, because one sample mean to say one variable or one series we have. So you can see here we have a one series. This is a one sample. If we have another sample, that is second variable, whatever, so that can be two samples. So I want to remove the one whole variable value. So what I can write here, n minus 1. That is important. Okay. So this is called the degree of freedom. So this is the general rule in one sample. If it is a two sample, we use 2. Okay, but here we use 1 minus 1. Now here I can use a degree of freedom. Okay, so basically guys, this is the real formula to find out the probability value. Probability value, that is a p value, you can calculate with this options or functions. Basically this is the formula, right? Okay, so now what is important, because it is right now only the one-sided one tail. So if you want to go with the both two tail, then we have to use a one minus. Very simple. So you have to use a one minus the whole equations here. Okay, so now the fully two tail we want to make it, so we have to be multiply with the two here. Okay, so here this is the whole formula for probability value, right, of or T stat, practically T stat for two tailed. Very simple, two tailed p value, because we need to go with the left and right side, because negative and positive we need to be check out. So guys, this is the way we can easily find out the p value here. Okay, so this is important to check out this stuff here. And here check out, this is a CDF here. You will see here, make equations, expression. This is good now. Can you see right now? This is good right now. Okay. So now my p-value is ready. Okay. So p-value is ready. Now can I print this p-value? Yes, I can print this p-value very easily. So here you can write this probability value. This is like a constant string. You can put it here. The probability round of this p-value. Okay, so now you can see out this is a p-value, and let's try to see what is the probability value come out here. So can you see the probability is 73%. Can you see right now here? The probability of this t value, this difference is 73%. This is not a lower probability, this is very high probability here. But now this is the idea to find out the probability. Now we need to calculate the results here. Before calculate the result, in the beginning, before starting our practice, I think we need to be calculate our hypothesis, or we need to be give our statement. So here somewhere we can give our statement here. So here you want to give your statement here. So what can be your statement or hypothesis? So you have to create your null hypothesis, that is the H0. We always tell that. Okay, what can be the H0? That is the your assumption, your statement, because you want to prove it. So we can write a mean sugar, mean to say the average of the sugar. You can write your own language. So mean sugar content, okay, is not significantly significantly uh, different or variate somehow from assumed population mean, because population mean to say population mean. Okay, population mean to say the general world population. Think about maybe 1000 energy drinks something. So right now this is the mean sugar content in our sample, mean sugar content of sample mean. Just it is good bad. Okay, so this is our hypothesis statement here. So we will use this statement somewhere to prove our result. Okay, so here we can put it here somewhere here. Okay. Okay, so now what we can do right now, we have to check out. So now we have to find out the threshold. Threshold mean to say the alpha value or limit, or somehow you can calculate the threshold. So generally in a statistics or data analysis, we use 0.5. That means 95% you must be sure. Okay, 5% can be the round off somehow. So you want to be check out. So general rule for 95% confidence interval. Okay, so now you can start your decision here. So you remember decision statement, if statement you can use. So example here, p value. So if p value is a lower than, lesser than this threshold, okay, and close the block. And then after, what we can use, just we can give our statement here. What statement? This or whole statement, which is I put it here. Okay, example here in the string, you can pass it here. Okay, mean sugar content of a, and here you can write a H0. This is your choice how you want to present your results. So mean sugar content of sample mean is not significantly different from assumed mean. Okay, so generally what happens, if the value less than 0.5, that means the mean is a different actually. Okay, so we have to check this hypothesis, we need to be accept or reject. Okay, so here you can write here, that means here what we can write here, rejected. Okay, rejected mean to say there is a real difference actually, practically there is a difference. Okay, rejected. Okay, and otherwise else part should be here. So else part will be no difference, this is true. Okay, and here, okay, and here we must accept it. Accept it. Okay, now you can see. So here, if you look out about our input, we have this input, and here uh, our null hypothesis statement was in the negative form, that is no difference. That means here we want to test or check our result with our value. So threshold value should be 0.05. That means 95% we are sure that our differences really exist. Okay, by default 5% chances can be the random by chance practically. So if you want to go more strict, you can go with the example 3. Now what happens, 97% we are sure, now 98%. So standard rule is 0.05, 95% we need to give the result here. That means if the probability p value, that p value here, it is 0.14, in that case what will happen, it is a greater than this value. If it is greater than this value, then else part will work. That means we have to accept the null hypothesis, that we are committing really there is a no difference, it is true. Difference when it comes, when there is a mean difference. Mean difference when it comes, you can change the value. Example, let's see 21, and one more, let's see 21. Okay, now compile, interpret the script again, and let's see what will happen. It is rejected, it is true. Now look here, if part is working here, okay, based on the condition here, because this value is 0.04, that means it is lower than the assumed mean, that means it is rejected. Okay, so that means really there is a difference. So I put in the negative sense, not significantly, then it is a rejected. Okay, that means there is a really significant difference. How we can understand? From this sample mean, it is 27.5, but the real mean, actual mean, that is the population mean, was 30. So you see there is a difference between 30 and 27, this and this. So what is the difference here? T value is telling us, T value is 2.27. That means sample mean is a lower. It is true here. So T is just like show the error or gap. So who is confirming the gaps? Standard error here, 1.09, it is here. Okay, and the T value is give the actual gap here. This is a standardized value. Okay, and probability, you see we have the probability value is 0.04. Okay, so you see here how we calculate with the CDF function here. Okay, so guys, this way we can easily understand our hypothesis, our results, and you can accept based on your idea. So this is very good idea to do that. Okay, now guys, this is the general idea to find out the difference between the two different type of a populations with the help of a one sample, because this sample is considering from the same population, right? So now this is the way to, this is a customized script which you made it. Okay, one by one step, right? But what we can do if we want to be how to say, if we want to be create it your own value, example with the functions here. It is also possible, but before that I think I will show the result with some graphical idea. I think let's go with it. So let's try to show the make a simple plot, example bar plot. Can we create a bar plot? Yes, we can create. But if you want to create a bar plot, you please go there, import, and there is a very important library, matplotlib. If you want to use it, matplotlib, and then after this is the library, and here you can use a pypilot uh, module here. Okay, and then after use a short abbreviation aliases, plt. Okay, so I will use a plt here, plt. Okay, and after plt, what I wanted to use, I will create example. There are a lot of you will see here. After plt you will have a long series of example. You want to see axis, arrow, or other. So here example, very easy to check out, bar graph. You need to create a simple bar plot. Let's study this some graphical visualization here as well. So here what we can do here, this is a functions here, think about. And in these functions we have to put our results here. Okay, so here, because how I cannot show example p value and t stat value, there is nothing. Okay, so I can plot this mu. This is because I want to show the difference here. So this is the mean value of the population, mu 30. It is given actually, and what we calculated from our random sample, that is the average here. Okay, so I will go for average and mu value. Okay, so I can plot here. Okay, this is the idea to use it. So this is the important to see, and make a short list here, just like a list here. Okay, and here you can decide the bar, example, which bar you first want to create it here. Example for assumed mean. So here what you can write here, assumed mean, which is actually given to us, right? Okay, this is the assumed mean, and then after our own sample mean. Okay, it is your own sample mean. So guys, here in this type of a list here, you can write a assumed mean. This is the first bar. This will be the second bar. Very simple. Okay. So first bar will be created and second bar will be created. Okay. And here you can give the comma. Create a second list. Look here, it is very simple to create a bar chart. Okay. And now first mean is assumed mean and it was over mu. Okay. Please see, it should be carefully only because here it is the value. Now I will pick the value, okay, from average. So this value will be printed on this bar, and average value, whatever the value we don't know, but it should be on this sample mean. Okay, so these are the bar, these are the values. Okay, and if you want to go for a more example customizations, this is your choice. Example, color. If you want to make some graphical color list here, so you can give your own choiced color here, example red. And one more color example, let's see, green. Okay, so and you can use a more width, height. Please see here, there are a lot of things, center, a lot of things, legends. Please read out later on this, but I think for today it is enough for create such a stuff. So now this is guys, actually my bar plot will be created. Okay, but some little bit customization is more important. What I can use here, y label. So y label mean to say what will be on my y axis practically. Okay, so here you can what you want to print here. So here example, we can print here, this is the sugar contents in grams, something like that. Okay, this is your y label. Similarly, must be x label. Okay, x label, what you can write here, x label you can write here, example, your technique which we learned today, one sample, t-test. Okay, this is your X label. Okay, and then what is the title of your graph? Example here, mean difference. Mean difference, that's it. Or you can write a whatever you want to do, and in the last, call show method function which can plot your result. Let's see, it should be plotted. I hope it will be plotted. Yes, can you see here? You can see this is the sample mean here. That assumed mean was, there is no significant difference here basically here. But based on the p value, it show the difference. Okay, you can also try to check out here. This is the threshold 5 here, and here let's see, it is the same here. You can see the average mean value of this content, and here let's try to change the value. Here example 35, let's see 20, 22, and let's see what will happen. What will be the sample mean? Can you see the sample mean is reduced? Okay, and assumed mean was 30. Okay, so can you see here sample mean is 28 and assumed mean was 30. Okay, the deviation value is a 4.8, huge deviation is coming. Okay, standard error is 1.2. Okay, the error little bit goes high, it should be less. So t value is a minus here. So can you see the minus 1.6? That is this is the difference here. So if it is a minus, that means sure sample mean has the lower value. Okay, so this is the probability here. So now here the mean sugar content of the sample mean is not significantly different from the assumed mean here. But here this is a significantly difference here. That's why I'm telling you, be careful. You have to create your null hypothesis. So mean sugar content of sample mean is not significantly. This is a rejected here. Okay, this is a rejected here. That means there is a really difference, so it should be accepted here. So this is your choice. You can write a alternative hypothesis. So in a stat you can write a null hypothesis or alternate hypothesis. So you can also write alternate hypothesis, but it is up to your choice. So please careful about this. Okay, so guys, I hope you can get it. So this is the general idea to do such a stuff. Okay, but now the same thing can we do with the automatic type of a functions in scipy we have? Yes, it is there, and it is possible to do the same. Okay, this was we done with our own idea. Okay, but what we can do here, so we need to be use a inbuilt functions. So in that case, we need to be use our inbuilt functions. How we can do that? So practically here, what we can do here. So let's see. We need to, I think we don't need use this data. So here, what I can write here, I can just remove this code here. Example, we don't need a probability, t value, se value, and here standard deviations, and the let it take it because graph will create it later on, but it is okay. I wanted to show you here. Okay, example here. Let's see. Okay, now very easy to create a p-value because p-value is not here right now. So I want to create a p-value and t-stat. T-stat. Simply you can write a t-stat. So this is your choice. You can write a t-stat first, or so better to be write a because first t-stat will be come out. So here t-stat p value. Okay, so till now we created by on with the traditional method, but what we can use stats. Okay, but can you see with the stats I cannot see how to say the t-test functions here. Okay, because I cannot see stats here. So in that case, what I have to use here, so what I can use here, here from scipy and import which module, stats, because I will use the functions. So I hope it will come stats here, where the function name should be uh, I think t test somehow t, yes, here. Can you see right now t test one sample? Please use this functions here. Okay, and yes, what we have to pass out here, or simply data set. This is your random sample and this is your list. I pass out here list. Okay, and apart from list we need to, because it will just a mean function, think about the mean function, but it will compare the mean of two series. First series is my list and second series is the given, that is the mu here. Basically it will create compare the two means practically. Okay, so the task is almost done, and here you can just print. So here what you can print here, you can write here example uh, t static. So you can write a t statics here very easily, and here you can write a format string here. It is good. Okay, and t statics, this is a constant string here, and here what we can write here, this is the placeholder. So who will denote this t stat? This one. Okay, and if you need a example again a absolute value or round off you want to do, you can do it very round off. Example, you want to do a round off here. Here you can try to round off here, round off by 2. Okay, so this way you can find out the t value. Okay, now what is left? P value. P value is also left out. So what is the placeholder for this one? I think p underscore value. Please give the right. Now it will automatically comes. You see, this is the p value here. Okay, so if you want to apply also a round on, round off here by 2, you can try. Okay, you see here. So you see this is done simply. So you will see here what will happen. Previously you see what we, the t value we want to also do with the same method. I hope it should work. This is the basically automatic, we using the functions with the scipy in the stat module. So let's see what will be the t value, and p value will be calculated for us. So let's see. I hope it will come. Here you can see, here I can easily see this is the, yes, it is the same right now. Okay, you will see the graph is especially different type of generated over here. It is also done. So guys, here you can easily see how we can find out the difference between the two different populations. Okay, so we can do very easily. Okay, so let's say to go on the notes, going to end the sessions, how we can do. So today what we had discussed, we try to solve a real world problem. Nutritionists claim that average sugar content in energy drinks around 30 grams. So they are claiming that in the cold energy drinks we have a 30 grams sugar content. That's why we took a random sample of 15 energy drink and we want to prove the results, really it is true or not. That is important. So you will see the hypothesis mean was 30. And what was our step we adopted? I used two things in today. Manual calculation. Example, we created the hypothesis first, then we created the t-value. So we can create the t-value with the only minus the two difference mean and divided by the standard error, right? And standard error, we can count down with the divide the standard deviations by square root n minus 1, right? So because it is the unbiased, we need it. That's why it is important. So t-stat, so difference of the two means divided by standard error. Very simple. Degree of freedom, we need to do that. And p-value, we can use with the cumulative distribution functions, okay, with the two tail. So please use that. And then after, check out your, cutoff or threshold. You can make customize. So here you can give your results. Is there difference or not? Okay. And then after, we in the last we use a automatic functions here. For that, this function will help us. Okay, so guys, this way you can do it any comparatively in the statistics, in the data analysis very easily. So this is the way you can do it. So thank you very much for your time. I hope you can get it. If you have any query questions, you can write me in the comment section. In the next lab, we try to solve any other problem with the new test. Okay, so thank you very much, and bye bye.